Hi students, today we are going to discuss about the magnetic elements of the earth. So as William Gilbert confirmed that our earth is equivalent to a bar magnet, he assumed that a huge sized, giant sized bar magnet is buried inside the earth. So it is behaving like the bar magnet, which is also having north pole and the south pole. Okay, if earth is considered to be as a magnet, then what are the magnetic elements of the earth? How we are going to study the magnetism of the earth? So the magnetism of the earth is also called as geomagnetism, and to study the geomagnetic behavior of the earth, three important factors must be remembered. So what are the three important factors which are called as the magnetic elements of the earth? One is angle of declination D. Second is angle of inclination or angle of dip I. And third is horizontal component of Earth's magnetic field, that is denoted by the symbol BH. So all these three are very important for solving the numerical problems in board exam as well as the competitive exams. So let us understand thoroughly about these three magnetic elements of the earth. Now children, you see the first picture. So this green circle, you assume that as our earth. Our earth is spherical, and you know that the earth is spinning about an axis which is passing through the north pole and the south pole. So this green circle is our earth, and this is the geometric equator. This is the geometric equator and the geographic axis. So here this is called as the north pole according to geography. So N suffix G I have written, that is geographic north. Similarly, this is south pole according to geography. So this is S suffix G means what? Geographic south pole. So based on the axis of rotation, on the top is the geographic north pole, and at the bottom is the geographic south pole. So imagine a globe and a pin is passing through the center, that is the geographic axis. Okay, so imagine another plane. Imagine a plane, a rectangular sheet, as if a rectangular sheet is inserted through the center of the earth along the axis of rotation. Imagine a plane is passing through the center which contains the axis of rotation. So imagine this is the second picture. So this rectangular sheet or the plane is passing through the center of the earth and also along the geographic axis. So this plane only is called, this imaginary plane is called as geographic meridian. Geographic meridian. Understand that? So this is geographic axis, this is a geographic meridian. Okay. Now our earth, see, for example, if a bar magnet is suspended freely inside this room, means it will be turning around, it will oscillate and finally come to rest along the north-south direction. Isn't it? What is this due to? Due to the magnetic field of the earth which is surrounding the earth. So earth is surrounded by a weak magnetic field. So now you see here, this is the magnetic axis. This is the magnetic axis of the earth. Earlier we studied the geographic axis which is passing through the geographic north and the geographic south. Very close to the north there is a pole. This is the magnetic south pole. Very close to the south pole there is another point where is located the magnetic north. So if you join these 2 points, what you will get is called the magnetic axis. So closer to the north pole, geographic north pole, there is a magnetic south. So S represents south pole and M represents magnetic south pole of the earth. Similarly, here closer to the south pole, this is a north pole. This is magnetic north. So if you join these two by a straight line, what you get only is called the magnetic axis. So my dear students, please remember that the geographic north pole is not coinciding with the magnetic south pole. They are separated by a small angle. They are not coinciding. So the two axes are making some angle with respect to each other. So if this is the geographic axis and if this is a magnetic axis, means they are not coinciding, they are crossed with each other. That imagination you should have. Similarly, we have imagined a plane passing through the center of the earth which contains the geographic axis. In the same way, you imagine another plane which is passing through the center of the earth which contains the magnetic axis. That imaginary plane containing the magnetic axis is called as what? Magnetic meridian. So this is magnetic axis, and any perpendicular line to the magnetic axis is called magnetic equator, and any plane which is containing the magnetic axis is called as the magnetic meridian. So the geographic meridian and the magnetic meridian are not coinciding with each other. They are making some angle. They are inclined to each other. That idea you should have. Okay. So that I have shown separately in the fifth picture. So can you see this one? The plane geographic meridian. So this is a geographic meridian. And the other plane which is inclined to the geographic meridian is called the magnetic meridian. Understood? So you can see here the magnetic axis, and a bar magnet is suspended freely, means it will show the geographic north and the geographic south. So the end point of the magnet which is facing towards the geographic north is called the magnetic north pole of this bar magnet, and the other end which is facing towards the south pole, geographic south of the earth, is called the magnetic south of the bar magnet. Understood? So now I have taken these two meridians inclined with each other, and this angle between the geographic meridian and the magnetic meridian is called the angle of declination. I hope you must have understood now. Okay. So what is angle of declination? For 2 marks definition if they ask, means how to write? It is the angle of inclination between the geographic meridian of the earth and its magnetic meridian. Understand? So it is also the angle between which two axes? The geographic axis and the magnetic axis. Naturally the same angle should be subtended, but for definition you write this is the angle between the two meridians. Okay. Next, what is angle of inclination or angle of dip? Very easily we are going to understand now. In this picture, I have shown two planes, two meridians. Now I will remove only the magnetic meridian separately and I will show here. In the sixth picture, I have shown only the magnetic meridian. So it is represented by rectangular plane. So this is a magnetic meridian, isn't it? And the longer side is along the y-axis and the shorter side is along the x-axis. So the shorter side is now forming the horizontal component of the Earth's magnetic field. So children, this one is called as the horizontal component of the Earth's magnetic field. Magnetic field generally we represent by the symbol capital B, and BH represents the horizontal component of the Earth's magnetic field. So this is the direction of BH. And this will be the direction of the vertical component of the Earth's magnetic field. Understand? This is the vertical component of the Earth's magnetic field. So here is BV. Now BH is a vector and BV is another vector. These two vectors are perpendicular to each other. So BH and BV vectors are perpendicular to each other. Now, how will you find the resultant of two vectors acting at a point using a parallelogram law or triangle law of vectors? So, one is acting along the horizontal direction, another one is acting along the vertical direction. So, the diagonal of this parallelogram, the diagonal of this rectangle will be equal to what? The resultant magnetic field of the earth, that is BE. So, this is the resultant magnetic field of the earth. E represents earth. So BE represents the resultant magnetic field of the earth. And the resultant magnetic field of the earth, BE, makes an angle with the horizontal component. This angle only is called the angle of inclination. Very easily now you must have understood. So how will you define angle of inclination or angle of dip? Angle of dip is defined as the angle subtended by the resultant magnetic field of the earth. With whom? With the horizontal component of the Earth's magnetic field. Understand? So the angle between this BH and BE only is called the angle of inclination. Okay, now you see this vector BE. This vector BE is going to be resolved into two components. So which is the horizontal component? This BH. So I will write this BH. The horizontal component is equal to BE into cos of I. Similarly, the vertical component BV. So BV is equal to what? This BE into sine of this angle of dip. So we have resolved vector into two components, is it not? So BE is acting along the diagonal. It makes an angle I with the horizontal direction. So the x component or the horizontal component of BE is this is equal to BH. BH must be equal to what? This BE into cos of I. Similarly, the vertical component must be equal to what? BE into sine of angle I. Okay. Now I am going to divide these two equations. See here, this BE into sine of I divided by BE into cos of I. So I have divided this sin I divided by cos I, so that the right hand sides will be what? B vertical divided by B horizontal. Now this field BE get cancelled. Sin I by cos I is equal to what? Tan I. And tan I is equal to BB divided by BH. So this is very important equation for solving the numerical problem. Many times in the competitive exams and in the board exam, this question has been asked. What will be the value of this dip? Find the angle of dip when the vertical component is equal to the horizontal component. The same question is being asked in competitive exams many times. So if BV is equal to BH, what will be the ratio, children? It will be equal to 1. So tan of I is equal to 1. For which angle tan theta will be equal to 1? That is for 45 degree. Understand? So these are very important informations. Okay, now special cases, let us take equator. At equator, the angle of dip I is equal to 0. Now substitute here, substitute in these two equations. What will be BH then? BH is equal to BE into cos 0. So this B horizontal is equal to BE into cos of 0. Cos 0 is equal to 1. Therefore, the horizontal component will be equal to the total magnetic field of the earth itself. Similarly, what is B vertical, children? This is equal to what? BE into sine of 0. Sine 0 is equal to 0. Therefore, the vertical component will be 0 at the equator. Understand? Similarly, at the poles. So now we will apply the condition at the poles. At the poles, this angle of inclination is equal to what? 90 degree. So substitute horizontal component BH. BH is equal to BE into cos 90. So cos 90 is equal to 0. Similarly, the vertical component BV is equal to BE into sin 90. So sin 90 is equal to 1. Therefore, the total magnetic field will be along the vertical direction. Okay. Now I will just repeat what are the three magnetic elements of the earth. They are the angle of declination D, angle of inclination or angle of dip I, and horizontal component of Earth's magnetic field BH. Now the first two definitions you must remember well. So what is angle of declination? It is the angle between the geographic meridian and the magnetic meridian. Then what is angle of dip? Angle of dip is the angle made by the total magnetic field of the earth with the horizontal direction. And the equation tan I is equal to BV by BH is totally important for solving problems. I hope you must have understood well. Fine.